All right, another solving rational equations problem. So here, none of my denominators are factorable. My two different denominators are x minus 6 and 3x minus 4. So what I'm going to be multiplying everything by is both of those denominators. And I'm going to work each one separately. So here on the left side of my equation, my x minus 6's are going to cancel. So I have 3x minus 4 times x plus 5. On the right side, the first thing I'm going to do is distribute 3x minus 4 and x minus 6 to my first part of the right side, the first fraction. And here my 3x minus 4 is going to cancel with this guy. Those two are going to cancel. So I'm going to be left with 3 times x minus 6. And lastly, I have to multiply 3x minus 4 times x minus 6 with this last fraction, 11 over x minus 6. So here my x minus 6's are going to cancel, and I'm going to be left with 11 times 3x minus 4. And now my fractions are gone, and we have an algebra 1, algebra 2-ish problem. So, lovely. Now you can solve. So, go ahead and pause the video, see if you can get ahead of me with the algebra, and we'll meet up later. All right, hopefully you tried this problem. I'm going to go ahead and get some steps done here. On the left side of the equation, we have to FOIL. So 3x times x is 3x squared. 3x times 5 is 15x. Negative 4 times x. And negative 4 times 5. And if you want to keep working there, you can combine those middle terms. 3x squared plus 11x minus 20. Left side of the equation is as simple as we can get it without factoring. So now let's work the right side. I'm going to distribute my 3. And I'm going to distribute my 11. So 11 times 3 is 33x. And then minus 44. And again, combine my like terms. 36x and negative 18 minus 44 is negative 62. And then we're going to get everything onto the same side of the equation. So I'm going to subtract 36x over and add 62. Bring over here, cancel. 11, positive 11 minus 36 is negative 25. And negative 20 plus 62 is positive 42. And now we're going to factor. So, we can factor or you can do the quadratic formula. The numbers are kind of big. So I would check to see if anything here is factorable. Lovely when your terms are factorable. So 3 times 42 is 126. And if you work the factor tree for 126, you get down to 7 and 18. 7 plus 18 is 25. 7 times 18 is 126. We need 2 negatives here to make negative 25. Of course, when I did this problem from scratch, I worked the factor tree from 1. So I started back at 1 and 126, 2, 3, 4, etc. I would work from the top. All right, let's factor. 3x squared minus 7x minus 18x plus 42. That is equivalent to the step above it because negative 25 is negative 7 minus 18. Cut it in half. I can take out an x. And out of 18 and 42, I can take a 6. And when I take out a negative 6, that ends up flipping the sign here in the middle to negative. So then my two sets of parentheses match. So you can think about it as whatever the sign is needs to come down. The other way I think about it is I'm dividing by negative 6. So it's going to make my first term positive, negative divided by negative. My second term's negative because I'm dividing that 42 by negative 6. Okay. You guys are talking about this anyway. Just in case factoring is not the thing that has come easiest here. A little abstract. Set each of your terms equal to 0, and we have some nice answers on this one finally. Add 7, divide by 3. Shoo! I'm glad we didn't have to do that. Oh, but there's a problem. One of our this guy right here. We didn't have this concern when we were using the quadratic formulas to solve because our denominators were very simple and our solutions were irrational. Here, with this solution of x equals 6, we go back up to the beginning and look at what our denominators give us here. X minus 6 is one of our denominators. So x cannot equal 6. If x is 6, we end up with 0 in the denominator, and you guys know that that gives us an infinite number of solutions. The other thing that x cannot be is 3x minus 4 cannot be 0. So x can also not equal 4/3. That's okay, we do get 4/3. So you guys want to take a look before you get really excited that you see your answer as one of the options, and take a look back at your original problem and make sure that both answers would work when you plug them in, that neither of them gives you a 0 denominator. And x equals 6 definitely gives us a 0 denominator. So our only answer here is 7/3. I'm going to go ahead and squeeze this next problem into this video. It's not going to make the video too long because we can do this in just a couple steps. Here we're just solving for k in terms of m. So what you want to do is get rid of your denominators. That's a good first step for solving. So here's my most complex denominator. If I multiply by 24, I'll get rid of the 24, but 8 and 6 also go into 24. So I can cancel an 8 with a 24 on top, and I can cancel a 6 with a 24 on top. The same thing, and I can cancel my m's if I multiply by an m as well. So we're going to use 24m to multiply each term by. I think it's going to be easier, so I need to write it like this. And color code a little bit. Okay, so my m's are going to cancel in this first fraction, and 24 over 8 is 3. So what I end up in this first fraction turns into 3 times 5. Okay, second fraction. No m's to cancel. I do have 6 and 24. 24 divided by 6 is 4. And then I have 7 and an m. And this m did not cancel either. So we're just working really slowly, canceling what we can, bringing down what we need to bring down. Other side of the equal sign. Our 24 m's cancel, and we just have a k. So if you need to pause and play that back, I think that was kind of a lot in one step. Make sure you're just doing the division, 24 divided by 8, 24 divided by 6, canceling m's where you can. And now we're just going to make our answer pretty. 3 times, clean it up. 3 times 5 is 15. 4 times 7 is 28. M times m is m squared. I have k. And here we were just solve the equation for k in terms of m. That just means that m we can leave as a variable. So here's your answer. K is by itself, m is our variable. Done and pretty.